Stars are the engines of the universe. They light up galaxies, create the elements that make life possible, and shape the evolution of the cosmos. But what are stars really? How are they born? How do they live? And how do they die? Let's explore the fascinating story of stars. The birth of stars. Stars begin their lives inside vast clouds of gas and dust, called nebulae. These regions can stretch across dozens of light years and contain enough material to create thousands of stars. Gravity slowly pulls clumps of gas together. As the cloud collapses, the material heats up. When the temperature and pressure in the core reach extreme levels, hydrogen atoms begin to fuse into helium. This nuclear fusion releases tremendous energy, and a star is born. The main sequence, the life of a star. Most of a star's lifetime is spent in a stable phase called the main sequence. In this stage, hydrogen fusion in the core balances the force of gravity pulling the star inward. Our Sun, for example, has been in this phase for about 4.6 billion years, and it will remain stable for about another 5 billion. Small stars, called red dwarfs, can live for trillions of years, burning their fuel slowly. Massive stars, however, burn their hydrogen quickly and may only last a few million years. The role of stars in the universe. Stars are more than just shining points in the night sky. They are the factories of elements. In their cores, stars produce helium, carbon, oxygen, and eventually heavier elements like iron. When massive stars explode in supernovae, they scatter these elements across space. Every atom of oxygen you breathe, every atom of iron in your blood, was forged inside a star billions of years ago. In a very real sense, we are made of stardust. Red giants and supergiants. When a star runs out of hydrogen in its core, it begins to change dramatically. For a star like our Sun, the core contracts and heats up, while the outer layers expand. The star swells into a red giant, hundreds of times larger than before. In this phase, helium fusion begins, producing carbon and oxygen. Massive stars, far larger than the Sun, become red supergiants. Betelgeuse, a bright red star in Orion, is an example. It is about 700 times the size of the Sun. The death of stars. How a star dies depends on its mass. Small stars, like red dwarfs, simply cool and fade over unimaginable timescales. Medium stars, like the Sun, shed their outer layers into beautiful glowing clouds called planetary nebulae. The core that remains is a white dwarf, a dense object about the size of Earth but with the mass of the Sun. Massive stars, however, end their lives with violent explosions, supernovae. These explosions are so bright they can outshine entire galaxies for weeks. Neutron stars and black holes. After a supernova, if the remaining core is between about 1.4 and 3 times the mass of the Sun, it collapses into a neutron star, a city-sized object so dense that a teaspoon of its matter would weigh billions of tons. If the core is even more massive, gravity overwhelms everything, and a black hole is formed. Black holes are regions of space where gravity is so strong that not even light can escape. Binary stars and exotic systems. Many stars are not alone. About half of all stars are part of binary or multiple systems, orbiting each other in intricate dances. Some of these systems can be extreme. When one star becomes a white dwarf, neutron star, or black hole, it can steal material from its companion, creating X-ray bursts or even triggering another supernova. Variable stars, cosmic beacons. Some stars naturally change their brightness over time. These variable stars are not just beautiful, they are crucial for astronomy. Certain types, like Cepheid variables, allow astronomers to measure distances to galaxies millions of light-years away, helping us map the scale of the universe. Stars and exoplanets. In recent decades, astronomers have discovered thousands of planets orbiting other stars. These exoplanets come in all sizes, from rocky worlds like Earth to gas giants larger than Jupiter. Studying the stars and their planets is helping us answer one of humanity's biggest questions. Are we alone in the universe? The future of our Sun. Eventually, about 5 billion years from now, our Sun will run out of hydrogen. It will swell into a red giant, engulfing Mercury and Venus, and perhaps even Earth. Then it will shed its outer layers and become a white dwarf, surrounded by a glowing planetary nebula. For billions of years, the white dwarf will slowly cool, becoming a black dwarf, an object so faint it no longer shines. The immortality of stardust. But while stars die, the material they release lives on. New stars are born from the ashes of old ones, and planets form from the same material. Life itself is made from these cosmic elements. Every star that dies sows the seeds for future generations of stars, planets, and possibly life. Conclusion: stars are the heartbeat of the universe. They illuminate galaxies, create the elements, and even dictate the fate of planets. By studying them, we are not just learning about distant suns, we are learning about ourselves. After all, every one of us carries the history of stars in our very bodies.